please. Cameron. Mr. Perry. Where y'all supposed to be? Get in the line then. I swear to God, Mom, I will be ready. So let's go. Yes. Whoa, let me see your book. Open your book. No, ma'am, come back. Open your book. It's a very big pattern. So now I'm saying I changed my way. Now I'm trying to scratch everything because it's time to use all the walls. If you need no guts, no, that's some gentlemen. Out, out, let's go. Hey, sorry. So you reading? You're reading. Welcome back. Welcome. What do you say? What do you say? Hi. We're reading. That's eighth grade. Now this is after they have made their web page, so they've finished their project, where you guys are still working on now.
You reading or you talking? Because I know what you're supposed to be doing. Okay, then I shouldn't hear you. Your iPad should be open. Clearly you think you're somewhere else. Jamar back now? Jamar. I think that's that. Stop. Stop. Zariana, take your hood off your head. Okay, you should be putting up your books, ladies. You're not talking. You're putting up your books, completing your ER.
I think he's at the door.
You don't think. It took you how long to figure that out?
Friends.
Ah, you made it to 7th grade with that delay in your common sense?
I guess so.
Well, I'm worried about you in 8th. You might want to become a little bit quicker. Or be quiet and don't let nobody know you that slow.
I'm slow.
Well, yeah, when I told you, when you quit with that, I opened it up. And I told you that, and you continued to do it and did it faster. So until you stop.
Yeah.
I need to hear my computers dinging. You're doing your ER. And if you don't have an ER, what do you do?
Just go on to the next thing.
No, you don't go on to the next thing. What do you do if there's no ERs on today's assignment? Anybody? Go to another assignment and open a complete ER. Row 4. Whatever it is, they got to do you competing at ER, so you don't care. Now, if I'm wrong, correct me. Stay focused on what you're supposed to be focused on. There's about 3 around the room that want some foolishness going on, but we're not going to buy into it. We have a lesson to learn. Earbuds are coming out your ear because you're not reading anymore. Yes. So far, I've only asked you to do 2 things: read and complete your
Okay, well,
ER. All right. Give me your attention at the front of the room, please. There you go. I hear them coming in. Where am I at? Today's assignment is abstraction. We'll talk about that in a little bit, but we're going to get to the point. The standard is MSCSFCP 3, and it's to utilize computational thinking to solve problems. All right, take your earbuds out your ear. This is the second time I've asked. Thank you very much. The standard itself or the element is develop a working vocabulary of computational thinking, including sequences, algorithm, binary, pattern matching, decomposition, abstraction, parallelization, data, automation, data collection, data analysis, booleans, integers, branches, if then and else, and iterations, loops, for, and while. So now that's a lot in one big jump. So what we've done over the week before you went on break was we broke it down. You had to define these words, and then we talked about sequencing, right? Sequencing means to do what? Take one in order, one step, one process after another, in order. That's all it is. All right, it's just like my granddaughter did the scratch this over the break, the first part of the break when she was interested in it. And she did, I'm gonna see if I can find it, the bear. And she realized that there was a sequencing code, it might not be in this one, yeah, for the bear. And she could make him walk. Let me pull him back. And if you watch his legs, one step after another. That's a process, simple process. Some of you have this in your game already. Somebody had it in their game where the cat walked up to the van, and then the van moved, steps, processes. All right, one thing happens after another. It's just that simple. Now, in the same context, when we start talking about sequences, there's algorithm. What is the algorithm, Mr. Pope? Algorithm. Algorithm.
Letters.
Nope, not letters. What is algorithm?
It's like an equation.
An equation? Yeah, I can go with that. Talk to me. Talk to me. Yeah, if equation wasn't wrong, you know you can't be too far off.
Operations.
Operations,
Expression.
expressions. All right. It's putting it together and making things happen. In math, it's 2 plus 2. All right, algorithm, putting it together. We'll get a little bit more than that. Then we'll talk about binaries. Binaries is where we're at today, and that's where I'm gonna put the main part of my focus. And then we'll move to abstraction, which sort of come with decomposition. Think of decomposition, you think of science. But before we get there, let's back up. Binary. Bi means what in English?
Sexual.
One.
Okay. No, the word sexual is totally different. But it means what? 2. Bi means 2. Binary means 2. Now understand this.
What's it by yourself?
Row 1. Thank you. Thank you. It's binary. It means 2. So in math, in binary and computer science, it is for us the number zeros and the number 1. You remember seeing that? Remember we talked about that a little bit? Okay. Pope, I'm this way. I appreciate you. If you don't have answers, you might need to be paying attention. So with 1s and 0s, you start thinking about the squishy games that you did, the squishy circuits you play with, and 1 or 0. Which one we got here? A 1 or a 0?
1. 0.
Why is it a 0? Because nothing is on, so it's off. So if it's off, it's a 0. So just the opposite of that means that if it's on, it's a 1. A 1. Now we can look at this in English. If it's true, it is. Is it a 1 or 0?
1.
1. So if it's false, it's a 0. Does that make sense?
Yes.
Now, that's the simple part. So when you start looking at your coding for your game, is it on or is it off? That's what you're gonna ask yourself. All right. So if I wanted the second object to move, is it on or is it off? What cuts it on? What cuts it off? Those are the type of things I'm starting to ask. Look inside this one. All right, let's press the flag. All right, notice it's talking, but at certain points, certain things are on and certain things are off. Because when it first starts, it doesn't start with everything being there. All right? So it came on, and then somebody said, "What's your name?" That became on, and then after a few seconds, the girl says, "Taylor." That becomes on. So when is it on? When is it off? Yes or no? Take your head off, baby. But what I want to do with you today in binary codes, and we're going to talk about bits and bytes, which comes under the term, but it doesn't show up right here. All right? A byte, a bit, B-I-T. It's just one. It's single. Yes or no? On or off? Does that make sense? One bit. You can have one choice or the other. When you did the squishy circuit and you connected the connectors, it was either connected or not connected. One bit. Does that make sense? All right. Talk to me. Huh? Okay. We'll see if we can get to do it today. We'll hopefully get around to it. Now, what we're going to do after bits is we're going to look at bytes. This is 8 all together. So you got a bigger circuit to deal with. You got more choices. I can go from off to no, partially on, completely on. Or I can flip it where one is on or the other one is off. So it depends on how I code it as to what I get. I have more options. Does that make sense? All right. So now with that being said, there's a table. You have to use this binary table when you start coding, writing codes or programs for your binary numbers. The table goes in reverse. We count 1, 2, 3, 4, 5, 6, 7, 8, right? The table starts at 1, but after 1, the numbers double, and it goes the opposite way. So then we get 2. What we get next?
4.
Next. I only got one person in class. One person in class still.
Oh no, I'm just sped, so I don't know.
Your class is up there then.
So what, baby? So what'd you say, Adrena? 32? What comes after 32? 64. I'm going to stop here. You have seen these numbers. All right? When you start buying storage, you can get 1, 2, 4, 8, 16, 32, 64, 128, 256. Those numbers start looking familiar to you?
Gigabyte.
Gigabyte. When you're buying storage or buying flash drives or buying CDs, anything that you're going to use to store your information, Pope, I'm in front of you for the second and final time. All right, so that's what we're looking at. But now when we start to code with this stuff, remember, it's either on or it's off. So I have to figure the value of what I want to code. If I wanted to code the number 1, all I have to do is make 1 on, and that equals 1. Does that make sense? But now if I wanted to code the number 5, how do I get the number 5? What's the biggest one I can use for 5? 4. So the 4 is going to be on. So we got 5 minus 4 leaves us what? So what else is on?
2.
Is the 2 on?
Yes.
So we're trying to equal 5. Basic math.
4 plus 1.
4 plus 1. So what else has to be on other than the 4? The 1. So the 1 is on. And the 2 gets a 0. So that is 5 in binary code. Does that make sense? Give me computer science is math. Give me another number. Keep it small so you can be simple with it. 10? Okay, we're gonna use the number 10. What's the biggest number we can use up here to get 10?
8.
So the 8 is on. So 10 minus 8 leaves us.
2.
What else is on?
2.
Keep your hands to yourself, boy.
1.
The 2, I'm sorry, I'm putting the 2 here. The 2 is on. So the 4 we don't use, the 1 we don't use, so they get zeros, and that's 10. Does that make sense?
Yes.
Half of you got it, the other half of playing don't get it.
It's kind of making sense.
It'll make more sense if you leave you alone. Don't look at me like you don't know I'm talking to you. Okay. Your hands, you can stay to yourself. I'm gonna tell you one more time. Now, give me one more number.
11. 2. 16.
8.
Which one we want? 11, 13, 8.
13. 8.
13. 44.
34?
44.
44?
21 sounds like a good number.
21 sounds like a good number? Well, we can do 21.
No, it's
Yep,
44.
21 and then we'll do 44 and we finish. Okay, so where are we gonna start for 21? What's the highest number we can use?
16.
So the 16 is on. So 21 minus 16 gives us what? How many?
5.
5. Where do we go next? 5. What's the biggest number we can use?
4.
The 4. So the 4 gets a 1. We're not going to use the 8. It becomes a 0, right? It's off. So we got 5 minus 4 leaves us. And what number do we use next?
1.
The 1 is on, so it gets a 1. We didn't use the 2, so it gets a 0, and that's 21.
10, 1.
All right, so now let's try 44. Where are we going to start?
32.
32 gets a 1. I got to subtract. Y'all know how to do this now. So I got 12.
Well,
She copied
and then you gotta do 8. You gotta use 8.
I got to do the 8.
She copied me.
So what happens to 16?
She's a calculator.
It's off. What number do we use for off? 0? Okay, so we got 8. 12 minus 8?
4.
What do we use next?
2.
We're going to use the 2?
Yes, 2.
Our number's 4. Look at our.
4.
We're going to use the 4. The 4 becomes a 1. So the 2 and the 0 becomes, and the 1 becomes 0, and that's 44. Now, with this here table, I want you to write it, then I want you to calculate your age in binary numbers. Oh, yeah. Let me see. Somebody's age might be up here?
No.
We good.
I'm 16.
That's why I didn't use 12.
I'm 16.
I'm 33.
You 94.
Actually,
I'm 64.
You better be figuring it. I'm coming to look at it in 1 minute. Use your Google Docs. Back row. Back row.
You gotta take that.
Your age in binary terms.
What's a binary term?
You got one more time to have an outbreak like that in my classroom. When we have this conversation with your parents and I rerun this video, you can explain to them why you don't know. Because I understand we just came back from break, but that's not what you're gonna do.
Okay, so I need to write.
Write your age. You might want to do the table. That ain't what I did.
But it's simple. That is.
That's not what I did. Okay. Should be a Google Doc.
He was supposed to.
I'm saying 8 by 10. She gives me 5 minus 4 equals 1.
Now put your A to the side like I did on before. And then plug it in. Remember I said the table go back? Remember your table go back? Guys, remember the table for binary numbers go backwards. It doesn't start with the low number and the higher numbers go to the right. The higher numbers go to the left. Come on. Google Docs, and let me see you doing it. Good job, darling. Nice start.
I'm not buying.
You better focus.
It's not that.
I think it's they did.
I don't care what you do, as long as I'm seeing it. The thing is, I'm not seeing it.
I'm finished. I'm getting.
You 12?
Baker.
So when you get ready to do this to go out the door, you don't know what you're doing, you got that zero, I want you to understand. I don't babysit. All right, somebody, I heard somebody say that 12. How do we write 12?
Minus 8.
Huh?
Minus 8.
8?
Oh, 4.
Because you gonna say you gonna understand this.
4.
I got the one on the 4. What's that?
You can subtract about 2.
Huh?
You can subtract about 4.
Okay, y'all, what is she doing wrong? What comes after this? If we don't use it, what do we do?
Put a 0 on it.
It's either on or it's off. It's either being used or not being used. And she's right. 8 plus 4 is 12. But we didn't use the 2 and the 0, so we couldn't just leave it open. The computer can't read an open spot. What it sees is if you're looking at a DVD or a CD, and every time you write on that screen, it puts an indentation in it. So what it does is either it's on or it's off. So if it's on, it's the indentation, then it get a 1. And if it's off, it gets a 0 and it keeps reading across it. So right here, when it get here, it's going to get confused if there's nothing there. Does that make sense?
Yes.
All right, so now somebody give me another number. Anybody, any age other than 12?
13.
13? 13. Hey, we don't have to do that. I can put both, I promise you. We can do 13 and then we're going to do 15. Your behavior got to get a little bit better in the back. 13, what am I doing?
8 first.
8.
I got an early bird. And then 4. Well, yeah. And then 1. Yeah.
What happens to the 2?
You gotta put a 0 right there.
That's 13. Who gonna do 15 for me?
I'll do it.
Talk to me.
Never mind.
What's the highest number you can use?
8.
Okay, we gotta do 8. So we take 8 and subtract it from 15, we get 7.
Yep. And then you have to do 4.
So when we take 4 and subtract it from 7, we get 3.
You do 2.
When we take 2 and subtract it from 3, we get 1.
And then 1.
And that's 15 in binary code.
94. Yay.
Does that make sense? All right, now, with that being understood, not understood?
Yes, I was shaking my finger.
Okay, with that being understood, there's an alphabet. You can take this and write words and sentences and whole letters to people and have it encoded where somebody can't really understand it. The alphabet goes just like the numbers, but instead of 1, 2, 4, and 8, you get A is equal to 1, B is equal to what? 2, C is equal to 3, D is equal to 4, E is equal to 5. So if my name was D, okay, if my name was D, I have to do this on separate lines. The D is on one line, the E is on the next line, and the last E is on another line. If my name was D, and the D has a value of what? I hear one person. D has a value of 4. How do I write D in binary code?
4,
The number 4. Now what happens to the rest of it?
0.
Zero.
So that equals the D. Now how do I write E in binary code? E has a value of 5.
So you use 4 and 1
I use the 4
and put 0 and 2.
and the 1.
That's a. Oh.
And you do the same thing. Yeah.
Yeah. Now when I write my name is D. Here's the bytes. I get 1 0 0 1 0 1 1 0 1, and that's D E E. Does that make sense?
Yes.
Now write your first name in binary code.
What if her name is Deborah?
Whoa.
You got your age for half of your points. Write your name for the second half of your
So we gotta
points.
make our own.
You can have a 0 or 50 or 100. I am here to help you. I will walk around the room. The first thing I would do is what?
You got a nickname?
What's the first thing you would do?
Write it out like that.
Do your numbers. Do your tape.
May I do a nickname?
No, I want your name.
It's my name.
Row 4. Do your tape. Now you already started this table in Google Docs when we did your age. So it's already there.
My first thing was 5.
What about I? You make our own numbers?
Yeah, take the numbers and just go right on down. It's 26 letters in the alphabet, so you know what Z is. If you want to write it out so you can see it, that's fine.
All I gotta do is look it up.
Yeah.
I think that's one there.
Can I get that one?
This number.
There's your email. Right, right. There you go. You did? Yeah. You did. Good job. Put that top, you can give us like a gift picture. Okay, when you start. So you start with the closed one. You right here. Okay, he's out. Oh, you can be there or not. You can't have a stop taking the back. Okay, move it up. It's on the side of the end of the. Well, no one around. Looks like the paper is on here. You had to put your numbers on. Okay. Okay, so you write the thing. We don't have time for that. That's why they send it in the table.
Now I got 5.
No, because I see it going down, like I did it in the chart. Does that make sense? Look at my camera a second ago. Yeah, please. What's up? Get out of there. Put it back here. You don't have to do that. That can be your name. Yeah. You good?
Okay, this what you.
C is 3. Okay, and then Check my first one.
Wait, these are the numbers.
Okay, now you gotta put them in binary form. Yeah, transfer from letters to numbers and then numbers to binary.
Oh, this just.
Yeah, she got that. Now what she had to do is, what's the value of J? J is 10. So you have to take 10 and do it in binary. This is the part where she's at. She has this. She just doesn't have this.
Okay, let me delete this. 'Cause I remember.
You might want to keep part of
I
that.
already remember it.
I play Pokemon.
Yeah,
You
come
good?
here.
Okay. The first letter of your name is? So you put the J right here.
She said I already have this one.
And the J has the value of, what's the biggest number we can get to get to 10?
The exact thing
So
you.
put the 1 in, cut the 8 on, put the 1 in it. Cut the 2 on, put a 1 in it. And put everything off. There you go. And that's J. So what's the next letter?
Okay, so we got a 0.
And A has a value of,
What do you mean, like what part?
is it this one?
Got you, bro. You got my her again.
She didn't write your name.
I was helping her. She don't even wear my
Hey,
name.
you got stuff? You helped her do his whole name?
Yes.
I only helped him with the letters. I didn't help him.
She gave me
Shut
all
up.
the answers.
He doesn't
She
even
did
know.
everything.
He said he needed
I
help
didn't
with the
even say-
letters.
No,
He
I
said
said
help.
I didn't say I didn't say
You can't help me.
Big
Then you gotta stop this thing.
It's fine.
So I using that. Yeah.
Huh?
Wow.
That's a letter.
Like, you go. I said, oh, yeah, no, 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 no.
I'm trying to.
What number it is?
What are you working on? Come on, where the rest of them?
I guess it's a letter part.
You got it?
That's what you do.
Alright. So we got most people on track. You understand what you're doing?
I have no idea what I'm doing.
Real quick. Abstraction in, what's decomposition? What's decomposition in science?
You gotta.
Decomposition means to what?
Decompose.
Decompose or
Break down.
break down. Abstraction is pretty much the same thing. It takes it and pull it apart. All right, you're gonna take out the simple part so that you can make the rest of it fall in line. Or you're gonna take out the hard part and get the simple stuff, and then you put it back together as a whole. And that's really what you've done right here in a way. All right, you looked at the alphabet, you numerized it, then you put it in the chart. So abstraction. Abstract means to take something out and take apart. To take out steps and make it all, try to figure out what's going on and work out. Does that make sense? So with that, you have videos to watch on abstraction for today. After you watch your videos, choose which ones you want to watch. Then work on your game, your studio code, and in your Google Docs, you're going to do a reflection journal and create a truth table with not, or, and, or. Not and or, a truth table. So now that's going to cause you to have to do a little research because you haven't got to the Booleans yet to start talking about the nots, the ands, and the ors. But when I come to them tomorrow with your reflection, you go back and see what you got right, what you got wrong, and we'll fix it. Does that make sense? Today you're going to go through and try to figure out abstraction for yourself, just looking at the video. And then what do we mean with Booleans when we say and, not, or? How do we write them? There's a symbol form, and they have certain nods that's on them that you can cut them on, nodes, I'm sorry, you can cut them on and off. Is what letter in the alphabet?
That makes no sense.
Is what letter in the alphabet?
I don't know.
Computers don't read letters, they read numbers. They read two numbers. What two numbers do a computer read?
1 and 0.
1 and 0. So if it's not in 1 0 1 0 0, they don't understand what you're saying.
1 0. Okay, I finished.
So if you wanted the computer to write your name, in basic terms, if you wanted to write your name, you would have to put in the code for your name in binary with 1s and 0s, and then the computer would read it and it would write out your name.
Oh, so that's how you gotta do it on.
Hmm?
That's how you gotta do it on.
They have done all that for you. all you're doing is dropping and dragging. You're not actually writing code in the basic sense. Does that make sense? The ones and the zeros have been added to create the movement block, to create the turn block. Yeah, so you don't have to do any of that. Yes, sir. Yes, sir.
I finished.
Why do I have to write my name?
You're gonna show it to me on the way out the door.
Oh, show both of them?
You're gonna show me your age and your name and binary code
Okay.
and get your grade. Or you get a 0. I mean 50, 0, 100. It's totally up to you. Where is you? I'm standing here literally having a one-on-one with you after you done played with her when I started.
I was not playing.
I literally stood here at this board and watch you reach over to her and watch her take her hand and push you away. Now I need to run the camera to show you that. Don't lie to me. Don't lie to me. But I'm still standing. I'm still standing here to help you.
Yeah, that's.
But all you got, you have there you go. You got all the energy for him. But you can't tell me where you're stuck at so I can help you. All I can get is 1 0 0 0. I don't understand why we're doing 1 0. So I tell you that's all this computer can read. Where are you at now and need my help? What are you trying to do? Have you written your age? How old are you? You don't know how old you are.
Yes.
Don't do that. How old are you? Okay, so let's look at the numbers. Are you with me? We start with your age. And then look at the chart. What's the highest number you can use to get to your age? 8. So the 8 will become a 1. And then what you have to do is subtract 8 from 13. And what's left? 5. Then we go back to the chart and look at the can get to get to 5, which is 4. So the 4 becomes a 1. 1 means that it is on or true. Is what we're going to use. All right? You have to use it. So you tell the computer, when you see the 8 and when you see the 4, recognize it. So now 4 from 5 leaves us. So what number do we use now? Okay, so now the 1 becomes on. But there's a number in between. You can't leave it blank. Because when the computer or when is reading, it's going across the surface, right? And if it sees something, it recognizes it, stops, and it picks it up. But if there's an empty spot in the process, you ever cut it on and it just continue to turn and turn and turn and nothing loads, that means that something is not picking up. So it has to be true or false. So we got the indentation for the 8. We got the indentation for the 4 to say it's true. We got the indentation for the 1 to say it's true. What happens to the 2? Because we can't ignore it. It's in the process. It's in the step. So is the 2 true or false? If we used it, it was true. If we didn't use it, it was false. So do we use the 2? So it's false. It gets a 0. Oh, that's the wrong one. True, true, false, true. And that equals 13. So if the computer sees these numbers, it'll know that the added value is 13. You still with me? Where'd I lose you at? You got the numbers. Now with the letters, all you gotta do is think of is the alphabet. How many letters in the alphabet? 26. So what we're gonna do is we're gonna come to Google Docs. Some people actually did this, others didn't. And we're gonna say in this document that A is equal to 1. Let me make this bigger so you can see it. And if A is equal to 1, I said plus. Make this bigger so we can see it. Is this good? Okay, so B is gonna be equal to what? 2. C is gonna be equal to, D is gonna be equal to, E is gonna be equal to,
Or
I don't do that.
he's gonna be equal to 5.
F is gonna be equal to,
6. 7.
does that make sense?
Yeah.
What's the first letter in your name?
J.
So I is equal to, huh? Okay, so you know where it's at. I is equal to, and J is equal to, so the first letter you need to write is a 10. Using the same format we used over here. So now what we're gonna do is just take our board, and it is 32, 16, 8, 4. Notice the numbers go back. Anytime you're doing a binary table, you start from the highest and work your way back. But if you look at it this way, it starts with 1 and it always doubles. Does that make sense? Okay. So with that, we're trying to get to the number 10 on this table. What are we going to use? What's the highest number we can use to get to 10? So under the 8, since it's on, we put in a 1 or a 0. 1. So 10 minus 8 is, so what other number are we going to use on the table? And so the 2 is a 1 or a 0. It's on or off. We're going to use it or not use it. If we use it, it's on and it's a off, on. Not used, used. False, true. No, yes. Not used, used. What number are we using? The 2. What is the value for true? Is it on or off? So now we did not use the 4, so it gets a, and we did not use the 1, so it gets a, and this is the number 10 in binary code. Oh, but the letter J in binary code. Yeah, you gotta do your whole first name.
It's right here.
And uses a U, which is
Hmm?
21 in the alphabet.
Your name uses it.
U, yes.
Okay.
And I can't make a U, like a 21 out of any.
What's the highest number you're gonna use to get to 21?
Oh, I guess I can't do it.
What's the highest number you're gonna use?
I don't know, 16?
16. So the 16 gets a 1. And when you take 16 and subtract it from 21, what's left?
Oh,
Not 7. That's 22.
Wait, what'd you say? Already figured it
We
out.
did the number 21.
5.
I figured it out. I heard 5.
What do you need?
Oh, it's backwards.
Yeah, take your iPad and sign. You good? You still confused? You good? Do you need me? I try. That's all I can do. I went home with the concept that I'm not begging nobody to get nothing they don't want to get. You can fail if you want to. It's your choice. You should be looking at your video. What you doing? You want to go to the bathroom? Then you need to go quietly and come back quietly. Yeah, your hand is raised and your mouth is closed. For your video. And a grade minus cover. And now you got your videos on the site and taking up. What you doing? What are you doing? Let's go to our house. Oh, yeah, you should be in by now. Well, I wanted to talk to you with you.
Makes no sense. My phone look crazy.
Is that the value?
101.
So now what you gonna do? See what we did on the board? That first one is the value of 10. Let me talk to you up to through. Go ahead, guys. Okay. So if we take 8 and add 2, because both of those are on, 8 plus 2 equals 10. So if the next letter in the alphabet for me was a B, I would put, since the B can have a value of 2, I would put a 1 under the 2 and a 0 under the 1 because I'm not using it. And 2 plus 0 is 2, so I know that's B. Does that make sense? Talk to me, baby.
We can have a 1.
That's an A.
So you can do 1.
Yeah, you just put a 1 right here under the 1 and that equals A. So if the letter was E, which is the value of 5, what's the biggest number I can use up here to get the 5? That's less than or equal to this number. I can use 2. That's the closest I can get to 5. 4. So the 4 gets a value of 1 because it's on. 5 minus 4 is 1. So what's the next number I'm using? The 1. So the 2 gets a value of 0. And the 1 gets a value, if I get it right, of 1. So if I did the math to see if this was right, if I can keep it up here, 4 plus 1 equals 5. So all you gotta do is plug in, yes, I'm gonna use this number. No, I can't use this number to equal this number. You got your distraction video? Working on your studio code or either your game? Did you write the name of that here, code? Did you do your work and write the name of that here, code? Do you want help? You can out the ready. Are you okay?
Stop, boy.
The first thing you need to do is get a new document. And then you need to put that table up. You see, I got it purple. Remember 6432. So you want to put insert. So you want a table. You know how many numbers are that? 3, 6, 7. So you want to go over to the table. Go over, all the way over. You got 7, yeah. Now go down about 4. You want 6, go down. How many letters do you have? J-A-C-A-R-I.
What is this?
Okay, now.
If you don't shut up.
Now, put 32 in that one, no way. Go to the next one, put in 16. And it's all still going. Then take the half of here, please, now. Thank you. Oh, what are you doing? What are you supposed to be doing? Your name, right? Let's get to it.
Oh yeah, I know, I already seen it when I was in her class.
And now, how old are you? Put it right here. Go down. What's your age? What's your age? And now, what's the highest number we can use to get to 13 without going over? What's number closer to 13 that does not go over? Put it right here.
Okay, don't go over.
Wait,
no.
Put a 1 in the 8. So now, 13 minus 8 is not 5. What's the highest number we can get to 5 without going over? 5 minus 4 is 1. And that is number 13 down there.
I did not even tell you.
Okay, everything is up, but your name and your age and your name. Row 4, come by me. Row 3, come by me.
Miss Baker, you trying to hit me?
Look at my bone.
What's your name? What's your name?